5D is investigating the solutions and zeros of polynomials. For example 1, how many solutions will the following equation have? What makes up the solutions, well, the easiest way to tell how many solutions it has is just look at the biggest exponent of the polynomial. Biggest exponent is 6 here, so this has 6 solutions. Let's look at example 2. How many solutions will the following function have? So your first thought is just look for the biggest exponent. Well, this problem is not in polynomial form, standard form. So you'd have to multiply out, you have x to the 6 times x minus 5 times x minus 5, because it's to the third, so x minus 5 times x plus 2 times x plus 2 times x plus 2 times x plus 2. You'd have to multiply all this out in order to come up with the actual biggest exponent, the degree. So another way to do this, if you look and you just have x to the 6 times x times x times x times x times x times x times x, and what that does is that it's actually going to be to the 13th power. So your leading term is going to be x to the 13th. And so therefore we know there are 13 solutions. You could also just look back and you have 6 exponents, adding them up, 6 plus 3 plus 4 is 13. Moving on, what type of solutions will the following function have? So what we do here, first we have to look at how many solutions there are. It's in standard form from the biggest, so it's all written out as a polynomial. You have 5 solutions. Now we have to tell what type of solutions they are. So for this, we're going to use the calculator. So we put the equation in the calculator into y equals, and then you go, I usually tend to go to zoom 6, and what this does is it gives you a nice window, negative 10 to 10 on your x-axis, negative 10 to 10 on your y-axis. I can see here that the graph goes through the x-axis. It looks like one time here. What I'm going to end up doing is I end up zooming out one time just to see if for some reason it was outside my window that it would cross over again. You can faintly see here that it goes across the x-axis once, and I don't see it going across the x-axis again. Anytime it goes across the x-axis, the graph, that is a real solution. So of the 5 solutions, there's one real solution. That's where it crosses the x-axis. If there are 5 solutions and one's real, then what are the other ones? Well, the other ones are 4 imaginary. So there are 4 imaginary solutions and 1 real solution. So what type of function will the following have? Or what type of solutions will the following function have? So you should be telling yourself, looking at x to the third minus 2x squared minus 4x plus 8, that there are 3 solutions. And the way we are going to find these solutions is going to the calculator. After I put the equation in the calculator, I'd go to zoom 6 just to reset my window. I see that it crosses the x-axis once here, and then when it comes down, at around 2, 3, somewhere in there, it comes down, hits the x-axis, and goes back up. Anytime this graph does that, turns on the x-axis, we call that a multiple solution. That is, we're going to call it a double solution there. So there are actually 3 solutions. There's one from the negative x-intercept, and then there's 2 where the graph turns on the x-axis. So that all 3 of these solutions are real. So there are 3 real solutions. There are 3 total, so 3 real solutions. And there are no imaginary. So a quick little side note, if the graph ever comes down, hits the x-axis, and goes back up, this is called a double solution. We count it twice. And likewise, if the graph starts down below and comes up, hits the x-axis and goes back down, that is also, so anytime it turns on the x-axis, that is a multiple solution. In this case, it's a double solution. Alright, last one of the last problems here. What type of solution will the following equation have? So for this, how many solutions are there? Well, let's look at, it's not in polynomial form here, so we have power of 2 here, power of 3, and this over here is actually to the power of 1. So 2 plus 3 plus 1, this will have 6 solutions. Now let's go to the graph. So graphing it, put it in the calculator, zoom 6, and 1 solution. Don't know what's happening here, and I don't know what's happening here. So I'm going to zoom in on this area in here around the origin. So zoom, you can zoom in. Use the zoom in feature. You're looking at the tracer, and you want to zoom in on wherever you have the tracer, in the middle of that. Hit enter. Can't quite see a whole lot going on there, so I'm actually going to zoom in again. And you can see the graph comes down, hits the x-axis. If you zoom in a couple times, you can see it hits the x-axis. That's a double solution. So let's zoom back out. We have 1 solution from this negative x-intercept, 2 here, and then let's see what's going on over here. So I'm going to zoom in on that positive x-intercept. Move the tracer a little bit over so it's close to the x-intercept. Hit enter. This graph looks very much like a cubic graph, which it is. When it does that, it has that little turn of the cubic graph function. This is called a triple solution. So this is three solutions here. So when it turns on the x-axis, when it comes down, comes back up, or it goes up, comes down, that's 2 solutions because it's quadratic. This is a cubic shape, so that would be 3 solutions. And then the other one, let's go back to zoom 6. 1 solution comes and goes all the way through like a linear equation. This is the quadratic equation shape, so that's 2 solutions, and then it comes down, turns on the x-axis, but it keeps continuing in a cubic fashion. That's 3 solutions. So total this has actually 1, 2, 3, 4, 5, 6 real solutions. Okay. Graph a function with the following zeros. Zeros, another name for 0 is x-intercept. That's weird, x-intercept, but that's x-intercept. So we go to 2. It's going to cross the x-axis at 2. It's going to cross the x-axis. 3 over 2 is the same thing as 1.5 and negative 2. So I need to draw a graph. It could be a trinomial or a cubic function because there's 3 different zeros, and if you would change the zeros to factors, it'd be cubic. You could actually have more solutions. Here we have 3 of them. There could be more. Well, I'm just going to draw a graph that goes through all 3 points. So it starts down about here, comes up, it's got to make a turn to come back down, and it needs to make a turn to come back up. So something like this will work. You can draw any kind of graph you really want as long as they go through the 3 points. Alright, graph function with the following, I should know how to spell, following zeros. Zeros, again, just like it's x-intercepts. So we have negative 5 over 2, which is negative 2.5. That's multiple of 2, so that means it's going to be a quadratic shape. It's going to come down and hit the x-axis, come back up, or come up, hit the x-axis, and go back down. These two zeros are imaginary, so those cannot cross the x-axis. But it's going to, there's a plus minus, there's a subtraction and a plus, they're the same thing. So it's going to end up, the graph is going to come down, or it could come up. turn on the x-axis, and then actually hold on. So scratch what I said before. This is still going to have a multiple of 2 at negative 2.5. And it's going to form like a W. It just won't cross through the x-axis. Could be like this, or could be down here, coming up, in the x-axis, going down, come back up a little, and go back down. A turn here would be that those are imaginary parts. Come to class with any questions you have about graphing polynomials and their solutions. Thank you.